My name is Dr. Felix Ayodele Oyeleye, and today I want to talk about confidence interval in statistics. Now, it's important to understand that generally in statistics, what we do is that we study a population. And more often, when we study population, we have to take sample to study that population. Now, this introduces the concept of estimation to whatever findings we obtain from that sample we have obtained from the population. So, as long as we are not going to be working with every entity in the population, and we have to take sample from that population, the concept of estimation and probability becomes integral in statistics. So statistics is all about estimation. And there are two perspectives to estimation. We can think of point estimation and we can also think of interval estimation. Now, a point estimation is when we use a value like a mean, median, or mode to describe a whole data set. That is a point estimation. But there are times we may want to rather go for an interval or a range of or describe a data set within a range of value. That is where we talk of interval estimation. And of course, the interval estimation provides more information about our population characteristic than the point estimation. And this interval estimate is what we generally refer to as confidence interval. Usually, there's what you call the lower confidence limit. And of course, we also have what we call the upper confidence limit. Okay. Now, while the point estimate stands at the middle, the interval estimate is like casting a net into the sea, while point estimate is like using a hook to fish. Okay. So you are going to have higher tendency of catching your target even with a net. Okay, so what exactly do we estimate in statistics? Is either you are estimating the population mean or the population proportion using the sample mean, or you are even trying to estimate the difference of the mean of two samples you have obtained, or the difference of two proportions that you have also obtained. Now, again, in terms of confidence interval, the confidence interval is defined as a range of value within which we expect the true population mean to actually lie with a degree of certainty. Okay, and again, we have the lower limit, we have the upper limit. It's like casting a net to catch a fish. Okay, we want to estimate our population parameter, but because we have to work with sample, how sure are we that the sample statistic we have obtained actually truly defines the population parameter? So you're going to have the lower limit, you're going to have the upper limit. You're going to compute for it using the formula we have on the screen. We call it the operator. Okay, so we have the confidence interval, which is equal to the point estimate, which is our sample mean, and then we have the critical value, and then we have the standard deviation, and of course our sample size, as we have on the screen. So, but what's the implication of confidence interval? Okay, so depending on the sample mean we are trying to use to estimate for the population, it will determine if our precision is actually poor or is actually good. Okay, a situation whereby we have a wide confidence interval. The implication is that our estimator, which is the sample mean, will be a poor estimate. But whenever we have a very narrow confidence interval, like say 90 degree, okay, or 90%, our estimator, which is the sample mean, will also be the sample proportion, is considered a good estimate. Okay, so the wider our confidence interval, the less precise, okay, the estimator we are using to estimate for our population parameter. Good. So the next we're going to talk about is the fact that confidence interval can never be 100%. Now, again, the implication of this is that as long as we are working with a sample and we're not working with every entity in the population, we can never be 100% sure of what we have. So we talk about probability in statistics. So we look at the probability, the likelihood of our findings from the sample to be a true reflection of the population. And the confidence interval formula is indicated as the point estimate plus or minus the critical value and the standard error. So when you look at this, you have the point estimate, which is our mean, as we have on the screen, and then we also have the critical value, which is our z, depending on the confidence interval we are trying to use, settle for. And then we have our standard deviation, and then we have our sample size. Now, it's important to understand that as long as we work with sample, we are likely going to be dealing with a t-test distribution or a z-test distribution. Okay, so in what distribution simply talks about is how our random variable that we have obtained from our population can actually fit into a graph when we plot it in a graph. But it's important to understand that this t distribution and z distribution is determined by our awareness of the standard deviation of the population itself. If we are aware of the standard deviation of the population, then we are going to be talking of z distribution. But if the standard deviation of the population is not known and we have to work with the sample standard deviation, then we'll be talking of t distribution. So looking at this curve on the screen, we talk about the normal distribution curve. And this normal distribution curve tries to talk about the mark-off points, which are the critical value for our 95% confidence interval. So again, going back to the distribution in context, I've mentioned that Confidence interval try to estimate for population mean. And if we know our standard deviation of the population itself, then we'll be talking about z distribution. But if the standard deviation of the population is not known, then we will be talking about t distribution. But it's also important to understand that the more sample we recruit, okay, that is, as we increase our sample size for any sample we obtain, we're going to tend towards a z distribution. Okay, the more sample we obtain, the more we're going to tend to a z distribution. Okay, just like we have on the screen, because our curve is going to be gradually become normal with time. Okay, so the more sample, the more we tend to z distribution. But of course, what differentiates z distribution and t distribution is our knowledge of the population standard deviation. Okay, so again, it's important in research that we know that 95% confidence interval is the most common degree of confidence that we often calculate. But this is often an arbitrary position. The dynamics of the situation on the field should actually determine the confidence interval we should actually be working with. Now, let's look at it this way. Vital consideration. If your sample size is actually large, you're most likely going to be thinking of 99% confidence interval. So in other words, the larger your sample, your standard error is going to be very small. Okay, if you want a small error in your sampling, your sample size is going to be large. So the larger your sample size, the smaller the error you're going to have, and the more confidence you're going to become. But when you have a small sample, your confidence level will definitely drop. So for people that are working on the field, it's important you put this into consideration, that if you're working with a small sample relative to the entire population, you're most likely going to be talking of a lower confidence interval. Okay, but if you can recruit as many as possible from your population as a sample, then you are going to be more confident. Then working with 99% confidence interval. So this is it means this is the critical determinant of the confidence interval we should be working with, and this is what we call the standard error. The S over N. S here is standard deviation. It could be the standard deviation for the population. It could also be the standard deviation for the mean, okay, or for the sample. If it is for the population, then we're talking of Z distribution. If it is that of the sample, then we're talking of T distribution. Now, the size of this standard error will determine the confidence interval we're going to be working with. For a large standard error, okay, we're going to be working with what? 90% confidence interval. It means the error is so large, our confidence level will drop. But for a very small standard error, then our confidence level is bound to increase. Now, confidence interval has actually found relevance in research in academic journal. We use it to explain for statistical inference to establish the significance of the result we have found out in our research. Also in forest plot, in Fourier plot, in bar charts. Now, usually the confidence interval is intended to complement our concept of the p-value. The p-value is the probability that the result we obtain is actually true. Okay, so confidence interval complements this, and it's important to understand the scenario where it is appropriately used. Thank you very much. This is the much we're going to take on confidence interval. Don't forget to share my video, comment, like the link, and then you can subscribe to my YouTube channel. I'll see you in my next video. Thank you.